Please welcome Scott Johnston, Chief Operating Officer at Docker.
Good morning. Welcome to Azure OpenDev. We are so excited to be here this morning, and we're really looking forward to sharing with you in the next couple of minutes some really interesting ways in which Docker and Azure together can help you build, ship, and run hybrid applications. We're going to start with a brief overview of Docker, and from there we'll segue into today's announcement, which is that we're bringing Docker Community Edition to the Azure Container Service. And then we'll do a brief demo of how you can use Docker for Windows and Docker Cloud to build, ship, and run a hybrid application, a hybrid Java Linux application, to Docker Community Edition on Azure Container Service. We'll then share a second way in which you can bring hybrid apps to Azure through actually modernizing your existing traditional applications and using tools from both Docker and Azure to bring those to the hybrid cloud. Then we'll also demo how to use a tool provided by Docker, given to the open source community, to modernize those applications, which we call Image to Docker. Sound good? If so, please welcome me in joining Michael Fries, Product Manager at Docker. Thanks, Michael.
Thanks, Scott. Thanks, Scott. I'll just briefly talk about Docker and containers, and then I'll get to the demo. At Docker, we're building a containerization technology, and containers are a great way to take an app or some other piece of software that you want to run and package it up into a standalone package that you can share with your colleagues or deploy to test, QA, or in production. So a lot of people compare containers to virtual machines, but they're actually a little bit different. So instead of virtualizing hardware with containers, only the operating system is virtualized. So that means if you're running 3 containers on the same system, they actually share the same operating system kernel. But the processes are isolated and the file system is sandboxed so that each container runs in an isolated context and cannot impact other containers running on the system. So that means that containers are very lightweight. You don't ship around a full operating system with each container. They're also portable. You can run them anywhere where Docker runs. And they're secure because the container processes are isolated. And they're fast because the operating system is shared, so you don't have the full overhead of hardware virtualization. This is just to give you like an overview of the Docker platform. Docker runs on both Windows and Linux. We started out on Linux, and then thanks to the great partnership that we have with Microsoft, Docker was ported to Windows also and runs on Windows 10 and Windows Server 2016. You can deploy Docker on bare metal on-prem. You can deploy it in virtual machines if you want, or in the cloud, or any kind of hybrid scenario that you can imagine. On top of Docker, we have a bunch of great content on Docker Store, plugins, pre-made container images that you can start from. And then developers and ops can take that and containerize their apps and use it to ship apps and source code from development through testing, QA to production. Docker is part of a wider container ecosystem. So we work with more than 450 partners that provide content and plugins on Docker Store. We also make sure that Docker runs on a bunch of different operating systems, and that Docker works great on all the infrastructure that you want to use for running containers, including Microsoft Azure, of course. Docker is also part of there's other container vendors, so if for some reason you're not happy with Docker, there are alternatives. Docker is based on open standards, and we work very actively with the CNCF and the OCI to make sure that we're building on standard technology, so you have choice. Docker comes in 2 editions. There's Docker Community Edition and Docker Enterprise Edition. Docker Community Edition is based almost purely on open source software, and we make it freely available to developers and operators. Enterprise Edition is our product and subscription for enterprises that want to run containers in production. And it gives you a full container as a service platform to manage your kind of software lifecycle. It comes with enterprise support, and we certify Docker Enterprise Edition on infrastructure, including Azure. And we also provide certified content from vendors on Docker Store, both plugins and container images. OK, so on to the announcement that we have for you today, which is that Docker and Microsoft are bringing Docker CE to the Azure Container Service. So it used to be that there were a couple of different ways to run Docker on Azure. We at Docker built something called Docker for Azure, and the Azure team is maintaining the Azure Container Service. So what's happening is that Docker Community Edition is now going to be available as part of the Azure Container Service. And it's the first step of Microsoft and Docker trying to converge and settle on a good way to run Docker on Azure. So what this is going to give you is a fully configured Docker Swarm running on Azure. And just to recap what Swarm is, it's Docker's native orchestration and clustering solution. It comes built in with Docker. And it comes with built-in load balancing, service discovery, and overlay networking. And it's secure by default. It has support for secrets and configuration management, and it's scalable, especially on Azure. So with that, I'll move on to the demo. And the demo I'll show today is that I'm going to start from a Azure Container Service swarm that I already pre-configured. Then I'm going to register that swarm with Docker Cloud using my Docker ID. And then I'll take a application that I have on my laptop, and I'll build and run it and deploy it on ACS Swarm. So let's move on to the demo. So the demo I'll show is I already set up a Docker Community Edition swarm on Azure Container Service. So what I'll do is I'll register that with Docker Cloud using my Docker ID. And then I'm gonna show you how you can use Docker for Windows and Docker for Mac to access that swarm from your development laptop or desktop, and how you can then build and deploy an app on Azure Container Service. As you can see here, I already set up a couple of swarms on Azure. The one I'm going to be using right now is this one, OpenDev 2. You can see this deployment, and there's a bunch of resources associated with this swarm. So this is all the stuff that's required to make Docker run on ACS. So some storage and a couple of swarm, master and worker virtual machines. So now I'm going to take the swarm that I already set up, and I'll register it with Docker Cloud. So I'm already logged into Docker Cloud, and I'll click this Bring Your Own Swarm button. And then Docker Cloud is going to tell me to run a registration command. And that is going to prompt me for my Docker ID. So I'll just log in. Like so. And then I'll be prompted for a name, so I'll call it Frism Azure OpenDev. And what's going to happen now is that this swarm will be registered with Docker Cloud and tied to my Docker ID. So if we go back to Docker Cloud, I can refresh, and you can see I now have an Azure OpenDev swarm registered on Docker Cloud. The best part, though, is that I can now access this swarm very easily from my laptop using Docker for Windows. So I already have Docker for Windows running here. You can see the whale icon in my system tray. So I'll right-click on that, and you can see I have a couple of swarms. I'll just zoom in. So these are the swarms that I have registered with Docker Cloud that I can use from my laptop. So I'll just click the one I just created. And I now have a console that's hooked up to that swarm. So I can do Docker PS to see what's running. I can list the nodes. So you can see this is a four-node swarm with one master node and three worker nodes. Just to show you how easy it is. Once more, I right-click, and then I can list the swarms and access it real easy. And the neat part is that I can share access to this swarm with my colleagues or anyone else that have a Docker ID, and they don't have to mess around with SSH keys or anything else, as long as they have a Docker ID. So that covers setting up the swarm on ACS and registering it with Docker Cloud. So now I'll actually try to do something useful and deploy an app that I have on my laptop. So this is it's an app called @C. It's like a web shop that we use for demo purposes. It's a Linux, Java-based microservices app, and it's already been Dockerized. If you want to try it out, you can clone it from GitHub. So it's got 4 services basically, and it's already been Dockerized. So you can take a look at the Docker Compose file. This is a file that specifies how each of those 4 different components are built and how they're supposed to be networked together so that the whole app functions correctly. So I can use that compose file to build the app with Docker Compose. So I'll do that right now. And I actually cheated a little bit. So I already built the app on my swarm, so the images are cached. So this build is really fast. So that completed now. And I can show you the images. So there's a bunch of images in this swarm, including the ones I just built for the @C app. It's these ones. Great. So now I built the images, and I can push those to Docker Hub. So I'll do that with Docker Compose also. So I'll use the push command. And that's going to take the images that are currently just on the swarm on Azure and push them to Docker Hub. And it's also pretty quick. All right. So now that the images are pushed to a registry, I can deploy the whole app on ACS. And I do that with Docker stack command, Docker stack deploy. Use a compose file again. And I have to give it a name, so I'll just call it @C. And so Docker's now going to look at that compose file, and for each service, it'll create a corresponding service on Swarm and network it all together so that the app works. So I'll go back to the Azure portal and find the endpoint where the app will be running. And it's this one. And I know it's going to be running on port 8080. So I'll just open that up, and hopefully we'll see the @C web shop running on Azure. Yep, there we go. So all the 4 services that go into powering this app are now running. Yeah, so just to recap, what I did was I took a Azure Container Service Community Edition, which is in preview. You can go deploy it from GitHub or using the ACS Engine tool. Then I registered it with Docker Cloud using my Docker ID. Then I accessed it from Docker for Windows because I was already logged in. That was very simple. And then I built and deployed the app on ACS in a couple of minutes, thanks to Docker and Azure. So that's it, and I'll invite Scott back on stage to speak.
Thank you, Michael. That was a really exciting use case for Docker and Azure and a really compelling demo. We'd like to share with you a second use case for Docker and Azure, and that is how to bring hybrid apps to the cloud, but starting with your existing traditional applications and modernizing those using tools from Docker and Azure to bring them to the hybrid cloud. Now, as context, microservices are obviously a very exciting application pattern, a very exciting new application pattern. And in fact, Docker is often discussed simultaneously with microservices. And of course, the reason is that the Docker container as a unit of application deployment is very, very sensical, if you will, to developers and operators. Developers build what's inside the container, and operations folks are responsible for deploying and managing the outside of the container and deploying it into production. And of course, the media has been quite excited about the rise of this new application pattern, and the analysts have weighed in with how it's going to help really revolutionize our software supply chain. And you've seen the rise of microservices basically parallel the rise of Docker. However, if you look at an organization and across their entire IT organization, you see that more than 80% of their applications are actually residing on existing systems that were pre-microservices and pre-containers. Moreover, if you look at it from another cut, if you just look at the spend of those organizations, most of their spend, 75% of their spend, is actually on existing traditional applications. And so it begs the question, what about them? What about those owners and operators responsible for those traditional apps as well as the apps themselves? Well, as we've been working on this with Microsoft and our customers, we've discovered that customers really are interested in an evolutionary approach to microservices. Instead of taking an overnight, very abrupt step and blowing up their applications, instead, they are more likely to start with an existing app, containerize that app. That gives the app a lot of exciting properties, which we'll talk about in a second. And then over time, factor out the common services that can be put into a container and made available to other applications. And so really what we're seeing is the journey to microservices is a step-by-step evolutionary approach, not a one-and-done abrupt approach. And so it begs the question, why bother? Why not just let those legacy applications sunset, retire, move on to net new greenfield microservices apps? Well, what we're found is that if you take an existing application and containerize it, and put it into that container and put it on modern infrastructure such as Azure, that you get some wonderful properties that the 10-year-old app even didn't even see before. Properties like much more portable between developer desktops, between developer and operations, between the data center and Azure public cloud. It's actually much more secure. The same application code is more secure being inside the container because it gets the benefits of isolation from the container isolation units that Michael discussed earlier. It is much more efficient in that it uses approximately half the infrastructure that it did when it was on-prem. And the portability means that you can actually move faster through your software developer lifecycle. So we're actually seeing improved agility from existing legacy apps that have been containerized and modernized. Really important, so once you modernize the app, how do you manage its lifecycle? Well, we're very excited to offer Docker Enterprise Edition, which is our container as a service product, a commercial product that is built on open source standards and technologies. And what it allows developers and operators to do is to together work on modernizing the apps, put it into a container, and move that container through the application development lifecycle. And what's important is that this platform, the container as a service platform offered by Docker, isn't just for legacy traditional applications. It's also for microservices. It's also for third-party ISV applications and anything in between. Basically, if it's inside a container, it can be managed by the Docker Enterprise Edition Containers as a Service platform. And so that flexibility for developers and operators that you have a single set of tools, regardless of the type of application, we found that customers are very excited about. So to help customers take this very first step on this multi-step journey toward microservices, we partnered tightly with Avanade and Microsoft to develop what we call the Modernized Traditional Apps POC program. This is a very exciting program that in 5 days will take an existing legacy application, modernize it, put it into a container, and put it on modern infrastructure on Azure, and put it under the management of Docker Enterprise Edition. And what we've seen from the results of this program, which we've been in private trials since December, several dozen customers have been through it, are pretty dramatic. We have a couple of public references. They appeared at DockerCon. We're really happy to share them again with you here this morning. First up is Northern Trust. Northern Trust is a large financial services firm. They had an existing legacy app built on Java Linux stack technologies. And by going through this program, the MTA POC program, with Avanade and Microsoft and Docker, they were able to reduce their deployment time by 75%. They went from 29 days to make a deployment to 7 days. On top of that, they found that they were doubling their infrastructure efficiency. They required half the infrastructure to accomplish the same performance of the application. And not the least of which, they are now able to put it on modern infrastructure, put it on Azure, and take advantage of Azure's elasticity benefits as well. Another public use case, another public reference is Microsoft's own IT organization. This is a .NET Windows application that was built on Windows Server 2003. And we were able to, again, within 5 days, come in and modernize 10 applications, containerize those applications, put them on Azure under Docker Enterprise Edition management. And you can see the pretty stunning benefits here. We were able to maintain the performance, maintain the scalability, while increasing the app density by 4x and reducing the infrastructure cost by 1/3. So obviously, really exciting results. You get higher performance with less cost, and who wouldn't be excited by that? What we've seen a lot of customers be excited about it, they are asking for tools to help them get started on this journey. And Docker is really excited to offer an open source tool called Image to Docker, which helps customers automate the discovery and modernization of their application. So I'm going to turn it back to Michael, and he's going to walk through this very exciting open source tool for you. Michael?
Thanks, Scott. Yeah, Scott mentioned we're with the Docker community, we're building a couple of tools that we call Image to Docker. We have two variants. There's a variant for Linux and one for Windows. And what they do is, as Scott mentioned, sometimes you may have a traditional app where it's running well on a server somewhere on a VM, but you might have lost track of where the source code is, or the developer that built the app originally is not around anymore. And we want to help users and enterprises that want to containerize traditional apps like that. So what the Image to Docker tools do is that you can take a virtual machine image that you exported from a production system or a backup that you took, and then Image to Docker will inspect those VM images for application artifacts that can then be containerized. What they do is basically inspect the VM image, and then we have a pluggable architecture for what we call detectives. There's a detective for MySQL, for example, and one for .NET, IIS on Windows, and so on. And then for all the components that are found in the virtual machine image, corresponding sections in a Docker file are created. So they're a great way to get started with migrating traditional apps into containers. So if you're interested in these tools, you can find them on GitHub. They're in the Docker organization. And I'm gonna demo the Linux variant right now. So on this system, I already have a VMDK image ready, and so I happen to know that this virtual machine image contains a LAMP-style app. So it's got it's Linux and Apache, MySQL, and PHP. And then I also have the Image to Docker tool here, so I can run that. So I basically just run. Well, it's going to create a directory actually. So I'll basically just run the Image to Docker tool and point it at the VMDK image that I have in this system. And what that's going to do is going to spin up all the detective containers that are going to go inspect the virtual machine image. And we can take a look at the output here. So it'll output a Docker file, and then the other artifacts that were exported from the image. So we can just take a look at this Docker file. It's not very easy to see, but it figured out all the packages that were installed in the virtual machine, and then it also extracted the different detectives, extracted sections for the Docker file. So there's some Apache stuff and some MySQL stuff and so on. Back to you, Scott.
Excellent. Thank you, Michael. So we think that's a pretty exciting demo of how Docker and Microsoft together can breathe new life into existing traditional applications. And in a couple of short minutes, we've shown you how you can take an evolutionary stepwise approach to microservices, and that modernization actually gives you real benefits. It can give you benefits of portability. It can improve the security of 10-year-old applications, and it can reduce your costs in terms of both infrastructure as well as people dramatically. We're very proud to have a program with Avanade and Microsoft. We're very proud to have a partnership with Avanade and Microsoft to help customers get started on this journey. We call it the Modernized Traditional Apps POC program. That includes Avanade Services, Docker Enterprise Edition product, and Azure Services. And finally, we showed how the Docker Enterprise Edition, a commercial product built on open source standards and technology, can help developers and sysadmins manage. We've shown how Docker Enterprise Edition, a commercial product built on open source standards and technologies, can help developers and IT pros manage the application lifecycle from the developer desktop all the way into the cloud. So thank you for your time this morning. If you'd like to learn more, here are some links. And again, we've shown two really compelling ways how Docker and Microsoft can help users build, ship, and run hybrid applications to Azure. You can go to the links to try out Docker Community Edition for the Azure Container Service. You can see the image to Docker tool up in GitHub, and we welcome contributions. And you can also go to the MTA link there and get more information, including links to demos and hands-on labs. Thank you very much. Look forward to seeing you online.